going to look at Introduction to SQL. Now, Introduction to SQL is basically we want to get the concepts about SQL, what SQL means, and what are the key points about SQL. Now, SQL stands for Structured Query Language. It's a programming language designed for managing relational databases, basically, right? And it's a standardized way to interact with databases, and it allows users to create, modify, and retrieve data from them, right? So, keyword, it's a standardized way to interact with databases, right? It's a language used to interact with databases. That's basically the summary of SQL, right? So, some key points about SQL, right, that we need to know, that it's commonly used, that we basically need to know, excuse me, that we basically need to know about is, so we can start listing them. We have database management system. We'll look into this keenly as we move on. Data management system, DBMS. It's said that SQL is used with a data management system such as MySQL, Oracle, SQL Server, Postgres, SQLite, right? SQL it provides the infrastructure. So these systems, these database systems, right? Since we use SQL with this database system, what does this database management system mean? It means that it provides infrastructure to store, organize, and manage data efficiently. So more on this. Now there's something we also call in SQL, we call DDL, data defining language, right? This SQL includes commands for defining and modifying the structure of a database. So remember we said we use SQL as a language to interact with databases, right? Now, if we use SQL to interact with databases, there are some commands that we need to know that helps us define and modify these databases, right? That's basically what this DDL means. So some syntax, some statements like create, truncate, alter, drop tables. These are syntax, these are languages that we use in SQL to define and modify the structure of these databases, right? Now we move to data manipulation language. Just like I said in data definition language, there are also languages and syntax that we need to be aware of, commands that we need to be aware of, right? That helps users to insert, to update, to delete, to retrieve data from these databases, to get data from these databases, right? And commands like select, insert, update, delete helps us with that, right? And then we have what we call querying and retrieving data. So SQL's primary strength lies in the ability to query and retrieve data, basically, right? What are we using SQL to do? We want to use this language, structured query language, to be able to retrieve data, to get data from 1,001 tables in a database that is useful for us. That's basically what we want to use SQL for, right? So the select statement is used to retrieve specific information from one or more tables based on conditions and criteria specified in the query, right? So basically, we need to be aware that SQL primary strength lies in the ability to query and retrieve data, basically. And then we move on to data integrity and constraints. SQL provides mechanisms to enforce data integrity rules, right, on the data stored in a database. So basically, when you are creating a table, you have like some commands that would help you store, that will help you create rules, right? Just like you want to have a primary key in a table, you want to be able to have a foreign key in a table, you want to be able to define constraints in a table, right? That will help you check for data consistency and integrity. So there are commands that helps us do that, right? That will help us enforce these data integrity rules when creating a table, right? That's basically what this means. So we also need to understand that there's what we call joins and relationships in SQL, right? When you have multiple tables and you want to get insights from different tables, right? There's something we call joins and relationships. So SQL supports the concepts of joins, which allows you to combine data from multiple tables based on common columns, right? So you have a lot of tables, but you want to combine some tables based on the common columns these 2 or 3 or 4 tables have, right? So that's that about data integrity and construct, or rather joins and relationship, right? So as I go again, he said it supports the concepts of joins, which allows you to combine data from multiple tables based on common columns, right? And it enables complex queries involving related data. Then we'll move on to aggregation and grouping. So we'll look at all these as we move on, right? Aggregation and grouping, SQL provides functions like sum, average, count, maximum, minimum, and so on, right? Which can be used to perform calculations on data and summarize information. So when you are talking about aggregation, it means that you are trying to collapse a lot of things into one, right? So just like if I say, give me the sum of the oranges in that basket, so you are definitely going to collapse everything and give me the total sum, which is a figure, right? So if I say, give me the sum of the oranges in that basket, and if I add them together, if I get the sum, there are like a total of 5 oranges in that basket. So basically you are giving me one figure, one aggregated figure, right? That is 5. So you understand? So we have syntax, we have commands like sum, average, count that helps us aggregate columns into a single or a summarized value, right? And it helps us perform calculations on our data, and also when we group data, it allows us to aggregate data based on certain criteria, right? So when you have oranges, and then you say get me the sum of oranges that have a criteria like that is spoilt, right? So you know that yes, we have some oranges in the basket, some are spoiled, some are okay. But now, because you have something like a group by option or a grouping option in SQL, you can also aggregate these oranges and then get and group them by the spoiled oranges and the not spoiled oranges, right? So that is like based on, that is what this means. Grouping data allows you to aggregate data based on certain criteria. And then we'll move on to transactions and concurrency control. SQL supports transactions, which allow multiple database operations to be grouped together as a single unit of work, right? So I think this speaks more on atomicity. When you have the ACID functionality, right, with SQL. So when you can be able to, when it supports transactions and multiple databases operations can be grouped together as a single unit of work, right? So it also provides mechanisms, right, to ensure data integrity and to manage concurrent access to the database by multiple users or applications. So basically, a lot of users can access this data concurrently, and no issues will overlap each other, right? Let's say I'm querying from a department called Human Resource Department. I'm querying a database, right? Another person from the sales department, right? Another staff from the sales department might be querying the same database, right? But because of this control, transactions and concurrency control, what this person is querying, or the scripts that this sales representative is querying or creating based from queries from the database will not even affect the HR personnel working on the same database. So that's basically what this means, right? That's like a picture of what this is saying. SQL is widely used by developers, data analysts, and database administrators for managing and working with relational databases. Now, what are relational databases? We've been talking about it. So we say relational database is a type of database that organization organizes and stores data in a structured manner. Very, very important. The type of database that organizes and stores data in a structured manner using tables. So structured manners meaning it must consist of rows and columns, right? That's the idea. Structured manner. So your relational database must be a database that organizes different data in a structured manner, which comprises of rows and columns. Very important. So here are some key characteristics. So we have what we call tables. So what tables mean in relational database is tables consist of rows and columns. We have this in our spreadsheet packages, right, where you see columns and rows, right? When you have a structure like that and data is being stored in that kind of structure, right, we can call that structure a relational database, right? And when we have unique identifiers, right, in that table, we can call that table a table basically, right? So if you notice, it says each table consists of rows, also known as records, and columns, also known as fields, right? And each row represents a unique record, and each column represents a specific attribute of that record. So basically, you might want to have a product table, and in a product table, you have a column called product name, product ID, product price, right? And then in each record signifies the occurrences or the description of a product name, right? So that's basically what this means, right? So we have primary key. So primary key is very important because this uniquely identifies each row. So a primary key in my product table would be a product ID, right? So for each product name will definitely have its own unique identification number. So in this sense, we call it a primary key column. So a product ID column in this my example would be a primary key column, right? Because it says a primary key is basically a column or combinations of column. Yes, you can have composite key where you have two primary keys. It's a combination of columns that uniquely identifies each row, right? Remember, a row can also be called record in a table rather, and it ensures the uniqueness of the data, right? A primary key is selected from one or more columns that have unique values such as an ID exactly or a username. Very important. So look at all this as we move on. And then we have relationships. So relationship is what makes us able to join tables, right? Because relationship establish connections between tables based on common columns. Remember when we said joins and relationship, right? We can be able to join different tables based on common columns, right? So that's basically what relationship means. So when you have connections between tables based on common columns, so based on common columns in the sense that in my product table, right, I have my primary key column to be a product ID, right? And then in my customer table, so we want to see the customers that bought so products, right? So I have a column in that customer table called product ID as well. So there's a relationship between those two tables, right? A column, they have a common column called product ID, right? Because in our product table, we have a product ID that uniquely defines each product name, right? For product ID 1, it comes with a name called channel bag, right? Product ID 2, it comes with another name called D&G bag, right? But now in our customer table, we want to be able to see which customer bought so product ID, right? And those product ID, we can track it back to see the product name in our product table, right? So that's basically it. So it gives us that relationship once you have common columns between two tables. So in this sense, customer table has product ID column and then product table has product ID column. So I can be able to join these two tables to get insights. So and we said we have common types of relationship in a relational database: one-to-one and then one-to-many. So one-to-one means each record in a table A is related to only one record in table B, basically, right? So each record is related to only one record in table B. So we look at this as we move on. And then one-to-many means like the opposite of one-to-one. So each record in table A, so in my head, each record in product column, or rather product table, is related to a lot of products in my customer table, or rather a lot of records in my customer table. Why? Because one customer can buy Chanel bags for different days, right? So definitely my product ID will be repeated in our customer table, right? So guys, stay with me. So you have a product table, you have a customer table, right? In our product table, we have unique identifiers, right? We know that yes, a product name called Chanel, a bag called Chanel would have a product ID, for example, 1. D&G bag will have maybe a product ID 2, for example. Then because in our customer table, which in this sense it is table B, most customers or a lot of customers might buy Chanel bags on different days, right? So definitely our product ID that describes Chanel bag, which is 1, would occur a lot of times, right? There will be multiple records in our customer table. So in that sense, if you want to connect these two tables, you want to relate them, it is called a one-to-many, because table A, which is our product table, has unique entry of product names and product ID, but in the customer table, it has multiple records, in the sense that a lot of customers might buy the same products for different days. So that's the idea, right? So let's move to data integrity. So data integrity enforces data integrity rather through various constraints, right? So we've spoken about this initially, right? So let's say you are creating tables and you are creating tables and you basically want some how would I put it, some functionalities in your tables, right? So you have like some syntax and some commands that would help you initiate data integrity throughout your tables and throughout your databases, right? So as it says, this constraint enables the data in the database to remain accurate and consistent. Very important. So common constraints, common commands that helps us with this in terms of data integrity are your primary key constraint. Exactly. So let's say you want to create a table, and definitely your table has to have, if it's a dimension table, right? Your table has to have a primary key, right? It has to have a primary key column. It has to have a primary key column. So what ensures that is what we call a primary key constraint, right? So when you're creating databases, you need to understand this concept. It's very, very important. So we have also foreign key constraints, right? So where would signify to a table that yes, there's a foreign key, a column that is a foreign key in this table, right? So you also have a unique constraint where you can establish the fact that there are uniqueness of values in a column, right? So you also have that not null constraint where you can establish. So all these are used basically when you're creating tables, when you're creating different tables, right? So all not null constraints would establish that in that column that you're trying to create, it will not accept a not null column. So there will be values, right, in that column. That's basically what all this constraint means. So it helps you lock and create integrity in your data when you are creating tables, when you are creating columns, right? So we spoken about structured query language initially, and we said relational databases are typically accessed and manipulated using a language called SQL. So the full meaning of SQL is structured query language, right? So we've said it in the beginning part of the video that SQL allows users to perform various operations on the data, such as querying, inserting new data, updating, and deleting data, and the rest. Now, there's also another functionality that we need to understand in terms of relational database, and it is basically ACID properties. So the meaning is basically atomicity, right, consistency, isolation, durability. So in terms of atomicity, this basically just signifies like you have a transaction, and in each statement in that transaction, maybe to read, to write, to delete data, everything is treated as a single unit. So one will not be left out, right? It's either the entire statement is executed or none of it is executed. That's basically what atomicity means, right? And then consistency, you have maybe when it ensures that transactions, right, only make changes to data, right, in predictable ways, in predefined ways, right. So what I'm saying is, so far there's consistency, transactional consistency, right. The corruptions or errors in your data do not create unintended consequences. That's basically what it means. So far there's consistency, right. So far there's consistency in your in your transactions, right. Sorry, I just got distracted a little bit. So far there's consistency in your transactions, guys, right. Your data would not create unintended consequences. That's basically what this means. We move on to isolation, right. So as I said initially, when multiple users are reading and writing from the same table all at once, you have multiple users, as I gave a scenario earlier, right. Everybody's writing, everybody's writing, everybody's updating from the same table, right, based on different departments or whatever, right. Isolation of their transactions ensures that the concurrent transactions don't interfere with one another. That's basically it. It does not affect one another. That's the idea. Then you have durability. Durability ensures that changes to your data made by successfully executed transactions will be saved. So in the event of system failure or whatever, something crashing, your system crashing, right. So any change that you've done to your data, right, that is successfully made would be saved. That's basically what durability means. So in that, we've looked at basic concepts of relational databases. We've also looked at key points about SQL, and so we would definitely treat all these as we move on. So see you on the next one, guys. Take care.